Hello everyone and welcome to this NPTEL online certification course of aquatic geochemistry, and today is the third lecture. In the previous lectures we have discussed the global water challenges, and I have discussed in detail how water is central to the sustainable development goals, and we moved on towards the One Health concept, how water is central to One Health in the fulfillment of the goals towards a One Health framework. And now I am going to talk about few future visions in the sense that when our problems, our day to day problems, we are slowly moving more industries, more urbanization, more population, our problems are also shifting, and to provide solutions to these new world problems, not new as a world as a different, but as a world as a more a population that uses more chemical pollutants and things like that, we have to have our solutions also moving at that pace to provide relief to the natural resource systems. And urbanization is one of the growth indicators all over the world. How many new cities are there, that is coming up in the next decade and all that. So every country is progressing, and urbanization is one key I would say indicator to assess the growth. And every urban city faces challenges due to water. What kind of challenges? First of all, what is an urban city? An urban city is a conglomeration, and there is a huge population. There are lot of industries will be there, lot of different types of shops and everything will be available, or lot of facilities will be there. So naturally it will attract a lot of population. So there will be a migration towards these urban centers. So as compared to the available resources, the population will be very high, and wherever the population will be very high, so they will be consuming the water also in that directly proportion, the water consumption will be also be very high, and the wastewater generation will also be very high. Okay. So in urban scapes there are related to water, of course there can be multiple levels of problem, but there are three very big problems. First of all, water supply, okay, to meet the continuously rising water demands of the city. So because every day if you check the population, there will be 1% increase, 2% increase, so like that so every year there will be a growth in population in urban centers. And second problem is how to and where to discharge the wastewater. What to do with so much of wastewater? As much as it is being consumed, a significant proportion of it is being returned as wastewater. Now how do we use that, or can we use that? And the third problem is treating, how do you manage extreme events? Okay, extreme events like if there is a flood, if there is a drought situation, how do you supply water in those kind of scenarios? And of course there may be very many other kind of problems also, but related to these three major challenges, a solution has been brought up, and that is to use treated and recycled wastewater. Okay. So you take the wastewater, you treat it, and then you discharge it into the river. Okay, because of course for rivers, abstraction of water from the rivers is a very big problem for the maintenance of river ecosystem health. And many times in the past we have seen many rivers dried up, narrowing down, and their if you talk to people, if the older generations, they will say earlier the river used to flow from here, earlier the river used to flow from there, and now you can't find the water. Where has the water gone? Of course, there has been some hydroclimatic alterations that has also naturally contributed to such variations, but human interventions are also a very big causal factor to cause decrease in water flow in the river channels. Okay? Because starting from the headwaters to all the multiple cities that are growing besides the banks of the river, everybody is trying to take some of the water out of that system. Now, like this, how long the water will flow downwards. So, if we can recycle the water and we can use it to restore and to recharge the river back, then that can be seen as a solution. So, many times we are seeing that our rivers are slowly being divided into canals to provide water for agriculture, for industries and all that, and what is returning is the wastewater. And this wastewater, if it is treated, then it is if it is treated wastewater, then we are having some hope that okay, it will not affect that much to the aquatic health and all, but long term studies are still awaiting in this kind of cases. And we India in this application of and assessment and impact assessment and all that is for rivers, it sometimes can take decades to understand how the the causal factors, the fine you can you're doing something right now, it might not immediately show up. So, it might take researchers to find the links between supply of treated wastewater and some ill effect maybe in some time in future. So, as of now we are still not seeing any visible changes, and therefore, at certain places wherever there is a lot of abstraction is happening and the return flow is required to maintain the E flow in the river, we are talking of entry of recycled wastewater. So, gradually that means our rivers are turning from natural to more human dependent systems. Why human dependent? Because while the river is flowing or not depends on the humans, how much they are abstracting, how much they are returning it back to the river. So, slowly from this beautiful flowing rivers, we are moving to this kind of system where the rivers are effluent dominated and sometimes dependent on the treated wastewater. And as I have already discussed in the second lecture, that our contaminants are also taken a huge different form. So, from just metals, from heavy metals and all that, now we are seeing more pollution and more impact of pollution from emerging contaminants, and that is from pharmaceuticals, from personal care products, from other polyaromatic hydrocarbons and other kind of dyes and all that. So, those kind of artificial chemicals, they are creating more trouble in the aquatic health as compared to what was traditionally we were thinking in terms of organic matter, in terms of heavy metals and all that. So, when these rivers are getting more effluent dominated and they are being dependent on these their aquatic health becomes more dependent on such kind of water, what is happening here? Okay, so, here is a small graph I have plotted, and that is showing how if you are throwing some treated wastewater. Now, here I would like to mention one point. Till today our wastewater treatment systems, okay, so there are different types of wastewater treatment plants and all that, and those plants most of the time are capable of separating out and mostly metals and some kind of viral loads, bacterial loads and some nutrients and all, but they are still not designed for specific target chemicals, especially for pharmaceuticals, especially for different kinds of antimicrobial resistant genes, for different kind of enzymes, for different kind of personal care products. Still we have to develop our wastewater treatment plants so that they can retain those pollutants. So, some of the pollutants in today's treated wastewater are getting retained back, but the other more newer kinds, more newly generated ones are not being able to get retained on those kind of systems, because naturally we are designed it for those kind of chemicals. So, they are being released into the water. Now, in the stream, when they are going into the stream, they are affecting, say suppose a pharmaceutical, some kind of drug, some kind of medicine, those drugs, when it is getting into the aquatic systems, it can start impacting the aquatic health. It will be taken up by the animals, by the microinvertebrates, by the macroinvertebrates, by the fishes, by the plants, and they may start showing some symptoms and they may start reacting. So, here is a small figure showing the in stream pharmaceutical concentration in this y axis, in stream effluent dilution in x axis, and as you can see that when we are dumping a particular contaminant, and dumping in the sense that I am not going and throwing it like that, but it is coming through either untreated wastewater or treated wastewater. So, initially the concentration is very high. So, when I am dumping on that day, the concentration will be very low. Slowly it will get diluted. Diluted means it will move away from that point source and it is moving towards the flow. Of course, it will flow away from the source of contamination, and this total this area if I take will be the effective exposure duration. So, that means for that period of time from here to here, this will be its effective exposure duration. Now, whenever I am trying to assess an impact, then I have to consider this effective exposure duration. Now, this increases when the introduction rates from effluent discharge exceed a chemical's rate of degradation. Now, here comes the important factor that is called the persistence time. When do I consider a chemical? Do I always have to consider a chemical? This depends on its persistent nature. Some chemicals have very short lifespan. That means, once they are into the air, water or in the soil, they start getting degraded. So, once they are out of the bottle, as they say, once it is out of the bottle, it starts degrading and its half life can vary from some minutes to some days, multiple number of days or sometimes even years. So, based on that half life time. So, what is half life? Half life is like if I have a concentration of a particular chemical, how much time will it take to reach exactly half of that concentration. So, suppose I have 10 gram of a compound X, and if in so to reach 5 grams of X, that is exactly the half concentration of the initial concentration, how much time does it take? Will it take 1 day? Will it take 2 days? So, that is the half life time of that compound X. Okay. So, if the half life is greater than equal to 2 or less than equal to 60 days. So, if it is between 2 to 60 days, it is considered as a persistent pollutant in water, soil and sediment interface. Okay. If it is much more greater, okay, in terms of like it varies between like 6 months or in years, then it is considered as a very persistent pollutant. Sometimes the degradation varies between the media, that means whether it is air media or water media or soil media, it can vary. So, same thing for air also, if its half life is less than 2 days, we are okay with it. Okay, we are saying okay fine, it is a persistent, but it is okay manageable kind of thing. But if it is beyond 2 days, then we will consider as a very persistent pollutant. Okay. Now, this kind of persistent studies are extremely important for understanding this effective exposure duration. And when I am talking, if you might think that I am discharging my waste in a small river in India, why will it matter, why will I somebody sitting in other places, say suppose you are sitting in Chennai, why suppose it will harm somebody back in Mumbai, or how it can affect somebody sitting in any other place of the globe. That to understand that, you need to understand that water is being circulated all throughout the globe, okay, and it is not that if you are using it in one particular location, it does not spread. So, water, it is very easy to spread through the pollutants to spread through water. So, by long range transport, due to their bioaccumulation in different aquatic systems, especially fishes, they can move from one location to throughout the globe. So, you can see through this humans and specifically through aquatic animals, okay, that are migrating from the rivers to the seas, and so it is a cycle. It is like one river fish that can enter the oceans, that can be eaten up by another larger animal, that can be eaten up by another larger animal. So, it is moving through the food web, and it can get easily transmitted to across the globe. So, this is what we call long range transport of pollutants, either it will be through humans or it will be through the fishes, but slowly we have found evidence of chemicals that are being used in very remote locations, or in sites which very selective sites, and we have found their evidence in the oceans and all. So, such records have been taken, and now it is very critical that we understand these kind of implications. And if you want to understand, and if you want to do research on these topics, I can easily refer you to this one book that is a summary. It has all the technical aspects, it has all the policies and the practices. So, it is on the persistent bioaccumulative and toxic chemicals, and since it is a book, you will find many references of scientific literature, and you can easily try to find those research more suitable to what your interests are. Having said that, we will move towards another important vision, that is increasing our understanding in biogeochemistry. And this is the first picture that I would like to you to observe, and then I will show you another image, and I would like you to understand the, and it might be a very common picture, you might see it, in any lake around your village or city or wherever you are staying. And sometimes we note such events, that is, as you can see, this is a fish kill event. Okay. So, a large number of fishes suddenly found dead in the lakes, and sometimes the environmental geochemist and the biologist specialists, they will be asked that why are the fishes suddenly dead, what is the cause of the fishes dying. And it is mostly seen in lakes which are stagnant bodies of water, and there can be many reasons what is killing those fishes, whether it is some particular metal, did the metal concentration increased suddenly so much that it was beyond the what is tolerance of the fishes, and it will easily move towards death, or was it depressed DO, and depressed DO is a very is related to a phenomena called eutrophication. So, was there a sudden release of a lot of nutrients that caused algal bloom? When there is a algal bloom, as you can see in the in the picture above, there is a green deep green color, that means there is a lot of single cellular organisms, and they basically block the surface of the lake, so much so that there is less exchange with the atmosphere and the bottom of the water, that is the lake water. And these organisms, they are, when they are doing photosynthesis or due to the respiratory activities, they decrease their oxygen in the water. So, then they will decrease the entire lake's oxygen concentration, and the fishes will be left with no oxygen to breathe, and they might die due to that case. So, this is what is called eutrophication, and during eutrophication something else also happens. Now, when these cyanobacteria and other kinds of bacteria are present, and they are during this eutrophication process, when they are populating, they are also dying, and they are releasing a certain kind of toxic chemicals. Okay. And these are commonly combined together and are called cytotoxins. These cytotoxins can also affect the fish, and they can also be harmed by their sudden high concentrations, or maybe there is some other contaminant, something that you are absolutely coming from outside of the natural system, like a pharmaceutical, okay, like a poison, something like that. So, was there some other kind of contaminant that is suddenly causing the fishes to die, or was there an oil spill event? Okay, when there is an oil spill event, that means the oil forms a layer on top of the water, and then there is again a lack of exchange with the atmosphere, and the oxygen concentration of the lake slowly decreases, and if it is the oil is not cleaned quickly, then the fishes might die in that system. So, there can be a multiple things that can happening, and initially whenever we used to see a fish kill event, we always used to think of some metal contaminants or some kind of eutrophication related DO problem or cytotoxins and all that. But now we are realizing that new emerging contaminants are much quicker in causing such events, such extreme events of life loss and all, and they are more they are more of the harming kind, and we need to understand our systems more and how they are impacting these aquatic life. And now that we are talking about lakes, and we are also I will talk about a little bit about the rivers, and I will show you these 5 pictures from the Ganga river and different locations along the bank of the Ganga river. Now, why I am talking about the Ganga is that it has been subjected to multiple uses, so industrially it has been used, the Ganga has been used a lot over in the past, and it is supplying water to approximately 500 million people in the northern states. It is absolutely the reason that we have the huge agricultural growth in the northern states. You will see, it is along the banks of the river, there are so many canals, Ganga canal, and that is taking away the water, and it is being supplied to places where there is high demand due to agricultural activities. So, Ganga has been supplying water for ages now to the Indian subcontinent, and it is the reason we call Ganga as a lifeline of India. It is also an extremely revered holy river for the Hindus, and we consider it as a goddess, as a mother, and that supports life and also liberates one from the life cycle. So, in different places you will see different phases of the river. So, in Haridwar the river is beautiful, it will it is flowing fast and all, and it's very it's a point where it drops from the mountain and it enters the flood plains. So, everybody, and Haridwar is a very holy city as well. So, at Haridwar you will have more of social religious kind of interventions. So, many people will come and they will do the rituals and all that, and in that process a lot of other contaminants can be released. There can be so pollution coming from organic waste, like people throw flowers, it is not throwing, it is actually they try to perform the rituals, but in the process they will add flowers. Now, imagine that these flowers, they, if there was any kind of insecticide spread on them to remove any harmful effects of insects and all that, that will come from these flowers and they will get into the river system. So, it is not that we are adding directly a pesticide, but through the human kind of activities, through human activities it is entering into the rivers. Or somebody is lighting a diya and it is releasing, they are floating it on the river, and that after a certain distance it might get overturned. Now, those oils that are getting released, okay, they are floating on the water itself. Thankfully, it is in a quantity that is less and manageable, alright, and it is not that we are seeing any oil spill kind of issue, but the point I am raising is these small activities, okay, also allow specific contaminants to enter from our uses to the river channel. So, even if we are saying okay, no, we are not doing any harmful thing to the river, we actually are doing it some other form. Or say suppose in Kanpur, it is absolutely different scenario. Previously it was the tannery capital of India, and a lot of tannery industries were there. They were the wastewater that was coming out from the tanneries, they were having different kinds of metals, they were having different kinds of dyes and other compounds that were extremely deteriorating the river water quality at around Kanpur. And even now if you go and see the river at many different places along that stretch of the river, you will see many places still openly dumping wastewater. And although our government has taken a lot of initiatives to clean the river, to stop such kind of untreated wastewater dumping, sometimes you will still have see certain places where you will see all this white foam floating on the river, and a lot of steps are being taken to curb such activities. Allahabad again is another different city, and a lot of human population is there, and it is dependent on the river. So, it is, I think you can see in the picture itself that bridges has been made on top of the river, and people are using it as for walking and for moving from one place to another. And there are two large rivers joining at Allahabad, that is the Yamuna and the Ganga, and it is a holy place again. So, a lot of social activities and religious activities will happen along those banks. Varanasi, again needless to say the importance of Varanasi in the Hindu culture, the importance of Varanasi, and there the crematory activities that is continuously happening is a significant source of pollution to the river. And again a lot of initiatives has been taken to directly stop the wastewater flow and clean as soon as possible, and trying to improve the water quality of Ganga. A little down from Varanasi there is Patna, okay, and you can see a bridge is being constructed for I think that was road that was being constructed. And such activities, the point I am trying to raise here is that we are used to seeing such activities for a very long time in not only Ganga, but all over India. We not only all over India, even all over the world, we see the rivers are subjected to such kind of human interventions. Okay. And how it is impacting the water chemistry, that is what is very extremely important to understand. So, we ourselves have to move towards slowly understanding and into improving our understanding of the biogeochemical systems and the activities that is happening due to such kind of intervention. So, there are some targeted measurements that we do, some bioassays that is done, and slowly we have to understand the toxicity related evaluations has to be improved, and policies has to be made to bridge the gap, to restore the river, to rejuvenate the river. And I think the government now is doing many such specific programs are being launched to clean the rivers and maintain the health of the rivers. Another future vision is understanding and monitoring the critical zone of the earth. Now, what is the critical zone? I think for most of you it is a new term, and it is not a new term in terms of for any geoscientist and all. So, the critical zone is that layer, it is called the living layer of the earth. From where does it start? It starts from the topmost point of the canopy. So, canopy is like the forest canopy, or if you have a different land use, so agriculture and all that. So, whatever is the topmost level, okay, from the trees, starting from there to your base rock of the groundwater. So, what is your bedrock? Till then, till that layer we call it the critical zone. Okay. So, it is the living layer of earth. Okay. Now, here a lot of processes are happening that is shaping the water quality. Okay. And as you can see that the critical zone encompasses the atmosphere, the soil and the groundwater layer. So, it is encompassing different layers. Okay. So, it is not like a single like atmosphere layer also. So, it is the entire thing that is living, that is full of life, that layer is called the critical zone. Now, why is it very important in terms of water quality? Because this interaction in the critical zone is what controls the chemistry of the flowing waters, and wherever it is entering, whether it is entering the lakes or whether it is entering the groundwater or whether it is entering the river system. These reactions that is happening while the water is falling from the clouds to through the atmosphere on top of the trees, it is getting accumulated, okay, on top of the land, that is the soil. It is again infiltration is happening and some evapotranspiration is also happening. So, that all that processes, and inside, once it is inside the soil, there some interactions are happening with the soil, minerals and everything, then either it can flow further down or it can percolate and being again uptaken by the plants and all that. So, this entire reaction pathway from starting, that is starting from the atmosphere up to the groundwater flow, okay, there are multiple reaction pathways, multiple time scales that is happening, and due to which the water that is flowing into the groundwater, or if it is an overland flow, that means it is not getting infiltrated any further, but it is flowing over the land. So, that is called the overland flow, that is the runoff. So, that is if it is entering into a stream or entering into a lake, that controls the chemistry of that aquatic system. Now, when I am saying understanding critical zones, what I mean is that this initiative was taken that we are going to assign certain locations as critical zones. So, at a particular place we are going to bring the labs. It is not that we are going to sample and then take to the lab, we are going to bring the lab to the field, okay. And by lab I not only mean chemical lab, there will be multiple other kinds of studies. So, it is a truly interdisciplinary kind of initiative. There will be biological study, there will be physiological study, a lot of geophysical activities going on, and at every the entire process will be divided into small processes, and different researchers are going to identify and understand and constrain how water is reacting in these different kinds of processes, how it is changing the water chemistry. At the very end of the process is what we are going to find out, what are the overall controls, okay, and how concentration and discharge relationships are maintained in a particular catchment. So, that will be our final outlook that I would say. And here is a small picture of a river lab, and this kind of units are actually set up in all kinds of CDZOs. These are automatic monitoring and sampling units. That means, since the number of samples has to be taken up in a much more shorter time duration, that means you may have to take a sample at every 1 hour duration or every 3 hours duration. So, every hour somebody has to be there to take the sample. Now, sometimes it may have you may have difficulty in providing so much of manpower support. So, automated systems therefore are created in such kind of labs, and these labs are equipped with all kinds of automated systems that will take up the water from the stream or from the lake or from wherever that you are setting up the lab, and it will take the sample at the regular intervals that you are fixing it, and it is capable of doing certain chemistries in that same interval, or you may have to take the sample back to your lab and do the separate lab work, that analysis may be done separately, but the sampling is done at a very shorter time scale, and this is I am talking about only for some chemistry related work. There can be a lot of sensors that are fitted on to measure and record soil measurements, or for they are also taken for the plants, how much evapotranspiration and how much uptake is being taken by the plants and all that. So, all kinds of interactions that is happening at a small catchment scale are recorded, are measured, are quantified, and we are therefore trying to have a robust and holistic assessment of how these water is interacting with the different components and how its chemistry is being altered at different scales and levels. And with this I come to the end of this lecture, and in the next lecture I will talk about water as as a resource, and I will move towards the physical properties, and we will talk about the hydrological cycle. Thank you.